So, hi everyone. Welcome. Good morning, good afternoon, depending on where you're calling in from. Welcome back to the Ask Me Anything series. I'm Mark Groot, Customer Success Manager at the Software Improvement Group. And today I'm joined by Werner Heijstek, who will introduce himself very shortly. Just like any other month, we have the Ask Me Anything series today, where you can submit your questions and we will try to answer them as best as we can. But before we do that, or while we do that, we always have a guest speaker to share some best practices around a topic that is of your interest. And today we have Werner for that. So I already want to say thank you, Werner, in advance.
My name is Werner Heijstek. I'm responsible for delivery at Software Improvement Group. I've been with the company for the past 12 and a half years. I've been mostly involved with either commercial activities or delivering our services. I have a background in science, worked at different universities in Israel and New Zealand. Still part of the faculty at Leiden University at the Institute of Advanced Computer Science, LIACS, where I do some research specifically in software architecture and software architecture design. But I will not spend too much time talking about that. Let's zoom in on a very practical industry application and talk about technical debt. Now, before I begin talking about technical debt, I'm always very interested what people think it is. So technical debt often is a topic that often comes up. It's a relatively old topic. I think it originates somewhere early in the 90s, so it's not new. And I think it has had many definitions. At least people have many definitions given to it. So I'd be very curious, Mark. I think we have a poll question ready. I'd like you to briefly tell me what you think technical debt is, what it is for you.
It's software processes that are holding you back from achieving your organization's goals.
So that's a process-specific definition.
Yeah, so process.
Oh, software/process. Okay, processes can be in the way, but technical debt is typically seen indeed as originating from the software itself. Processes can also be very much in the way. Indeed, they're high ritual processes that definitely do not help you speed up. So one way of thinking about it is that it's a shortcut. So you see this image here, there's this bridge, and probably building the rest of the bridge will take a lot of effort. If you put this little temporary solution in the middle, you can already cross the bridge, right? So essentially it's a shortcut, and you've now much quicker offered the feature of crossing this river. And that's it. So it's essentially a temporary solution that allows you to move faster. So this was originally not this briefly, but the original definition stems from the early 90s. Ward Cunningham is the person often accredited with the first person noting technical debt, mentioning the term. And the idea behind it was that you know full well that building a bridge like this is not a good idea. If you're a bridge engineer, if you're a structural engineer, this is not a smart idea. But if somebody's really, really pushing you and saying, sure, but we really need to get some stuff across right now because else we go bankrupt, then you're fine with it. But what you do is you make this deliberate decision to make this shortcut. And what you also do is you make a plan. So at the first moment that we have a little bit of breathing space, that we're not going bankrupt, that we apparently have made enough revenue to keep existing as an organization, then we are going to solve this particular piece of technical debt. So it's this whole idea of a conscious decision. Now, oftentimes how people talk about technical debt today is not like that. You typically talk about technical debt is I inherited the system/processes, like the definition that we got as an example. I inherited that, and that is what is currently holding me back to go as fast as I would actually like to go. And so you see slowly that this changed a little bit. Mark, you can go to the next slide. What you see is that to make talking about this slightly easier, different categories were invented to categorize sort of technical debt. So when you are carefully introducing technical debt and you do it on purpose, so you know what you're doing, which is the orange quadrant there, that's a measured risk-based approach where you have clear plans for repayment of this technical debt, to stay in the analogy of a financial burden. The opposite of that is that you're reckless, and you don't really think about the consequences of the way that you code, and essentially the technical debt that you therewith introduce is all by accident. It's completely accidental. So the technical debt is incurred unknowingly. People are not aware of it, And you only figure out that you had technical debt when there's some business implication. You leak data, somebody breaks in, or somebody vandalizes your website or system, or deletes stuff, essentially willfully breaks something, or your system goes down in operation and your clients actually can no longer use whatever service that your platform or your service or your systems are offering. And so the consequences of technical debt are not very clear. And of course, the consequences are myriad in that when your system goes down and you have a lot of technical debt, it takes more time to figure out why the system went down, and it takes more time to actually do something about it because it's a bit unpredictable to make changes to your system. So this is a way of categorizing technical debt. Technical debt is not a problem, but it is a problem if you're not sure that you're actually making it. And this is still not rare. So as a matter of my profession, I have to look at many software systems all around the world. I've done so. I've seen many systems, thousands of systems in the past years. And in many circumstances, you still see a large majority of developers incurring technical debt without really knowing that they're doing it. And in many cases, developers know that they're actually introducing technical debt, but they're forced to do so by business. You can measure how much technical debt exists in a system, and that will almost always go up because there's very limited resources and time available to actually solve technical debt. Because as a developer, when you solve technical debt, you have nothing to show for it from a business perspective. You don't have new features. The only thing that you have is that your system is now easy to work on in the future. That has a benefit. Of course, the benefit is increased productivity in the future. But this is not something tangible for the sort of the end users or the end group of people paying the bills and the business side of the organization, which always makes technical debt a very difficult topic to talk about.
Yeah, and I think I got a question on that already from someone in the audience who kind of already hints to that and says, "How do I like?" And I'm paraphrasing a little bit, but how can I convince the business that this is something to invest in?
Yeah, this is one of the biggest questions on the topic actually. So, how do I convince people that pay the bill that there's something invisible and that is problematic for them and that they don't really see now, but they might see in the future? Of course, the easiest people to convince are people who already went through something. If you were already at some point as a manager responsible for a system which leaked a lot of data or which had a lot of downtime as a consequence of how poorly the system was set up, of technical debt essentially, then of course you understand because you've seen this problem and you don't want to have that again, and you understand that you should spend a percentage of your development budget on avoiding this problem. This is one way, but of course this is not a very proactive way because you have to wait for things to go wrong. So another solution is to make very clear, right now we are developing on our application with 10 people, and that could be a smaller amount of people if we would have a system that was easier to maintain, easier to make changes to. And it doesn't mean that we have to make the team smaller, but it does mean that the team can now deliver more functionality in the future. And that's essentially allows you to reason about it like a business case, which is often the type of language that the audience that you want to convince speaks. So you say, sure, we need 1 sprint or 2 sprints or 10% or 20% of all sprints in the future, however you want to quantify this. And it really depends a little bit on what stage you are in and what the role of software is, but let's say 10% of every sprint. But what you get for this is that we slowly reduce the amount of people that we need to keep the lights on. And to just make sure that the system doesn't go down, but do the fun stuff, building new features that are interesting for our clients. So this is a common way. It's not an easy way, but it's definitely a way in which which allows you to speak the language of the target audience, and this is easier to convince them, or less hard. It's never easy.
No, definitely. I think one of the things that what really speaks to me, what you said, and I heard that from a customer, I think last week or the week before. It was a scale up, and obviously with scale up, it's about also growing their business rapidly, but but their IT should also support that rapid growth, right?
Yeah.
And what their CEO also said is like, we need to slow down now a little bit to speed up again.
Yeah.
And it's like slowing it down to speeding up again. I think that's also language that resonates. And it speaks directly to what you said.
Yeah, I think your example is the yellow quadrant here, where you're a
Yes.
bit reckless, but you know full well what you're doing. Okay, sure, we can do it nicely, or we can do it really quickly, and
Yeah.
it might be so that, especially in sort of startup and scale up type of environments, it might be really necessary to just survive. The only thing you need to know is what the short, mid, and long term consequences are, and make sure that at some point you actually slow down. And it doesn't mean you have to solve all technical debt. In fact, I would never allow you to solve most technical, never advise you to solve most technical debt. Most technical debt, you just stay where it is. But to address that technical debt that is really problematic for your business. Maybe we can talk about that on the next slide.
Yes.
There's a lot on this slide. The key point I want to make with this slide is that most technical debt should stay exactly where it is. Right? So again, I've seen many software systems in the past decade and a half, and every software system you see is full of stuff. There's not a perfect software system out there, and that's for the best. If you as an organization try to build the perfect software system, you will go bankrupt. That makes no sense. So every software system is full of challenges, issues, design decisions that were made that are no longer valid, design changes that were started but never finished. It's like archaeology, especially the larger systems in larger corporates. It's very interesting and fun. It doesn't help to sit down and point at all the mistakes. That's super simple. That's super easy. So most technical debt should stay exactly where it is, and that's the bar at the bottom. What you here see is the amount of risk on the y-axis, on the vertical axis, and you see the amount of technical debt on the x-axis, on the horizontal axis. And the most technical debt has almost no impact or risk, low probability, low impact risk. Often it's also in code that's not even being used. That's another problem, by the way. Many systems consist of lots of dead code and unused code, which you should be able to delete, but it's often not deleted, which makes these systems still very big and difficult to navigate. But if you look at the top, a small amount of technical debt is really important to address. Security, of course, now is a no-brainer, but when I started working at SIG 12 and a half years ago, this month, and I would ask a potential client, should we also look at security? They would look at me strangely. No, that's not a problem here. We didn't think about that. Of course, that really changed in the past 5, 6, 7 years, not even that long ago, where security now often is the first thing that organizations ask about. Now, you can only imagine what things are we not thinking about right now that will be, for example, I predict resiliency, reliability of systems will become a much, much bigger problem than it currently is seen as. It is a problem already, but it's not very talked about nearly enough, I think. But the effects of, if you have a security vulnerability and you find it in your software landscape, especially in an application that is public facing, more and more organizations will be aware of this. More and more organizations will have a policy around this. By not at all most organizations, but this is increasingly, there's awareness about this, that it's not just a sort of a policy that you need to have these 300 pages on the wiki and the security certification, but that this actually should be part of your definition of done, that you should actually measure these vulnerabilities and address them as quickly as you can, and also help your developers with that, because it can be very complex. How can they mitigate this? How can you actually write secure code? Same is true of reliability, and that, of course, there are many, many, many other topics. Cloud nativeness, scalability, there are many interesting topics there. These are objectively, this is technical debt. Company risk in the coming 1/2 to 2 years. So the key thing that you see there is productivity, which you can measure. For example, productivity is always difficult to approximate, but with maintainability. And maintainability is a degree to which you can make changes to a software system. It sounds like a technical model, but it really is not. It's really a model that is very human oriented. How easy is it for the average developer to make a change to your software system? And you can measure this, you can benchmark this, and you can also add economic indicators to this. How much more time do I need to change a software system of a lower maintainability rating, for example? Same is true of scalability. You don't have a problem tomorrow when you have technical debt that hinders your scalability, but in a couple of months you will have some problem, and in 2 years you will probably have a big problem, especially when you're the scale up that Mark just gave as an example. Now, some technical debt is subjective. I remember a client that said all our Delphi code is technical debt. We decided that if we see Delphi in our landscape, and they had, I think, about 50 applications, if we see Delphi, that needs to go. I also have clients for whom Delphi very much is a living and important sort of language, and that is very much part of their target platform still. They're not building new things in Delphi, but they're definitely building new things in Delphi. And so that's something that is subjective. So one company's technical debt is another company's sort of a revenue stream application type still. And so there's something subjective to it also. But I would venture that security, productivity are very much objectively technical debt.
So it's actually not a question that I got into the Q&A, but I think I can imagine this is a question on people's mind. At least the question is on my mind. How do you distinguish between that how do you filter on that high risk type of technical debt, or how do you get there from that big pile that you potentially have?
Yeah, so parts of it can be automated and parts cannot. So we're not yet at a stage where we can just drop a code base into something magical like this huge LLM and say, you know, get rid of the technical debt, or give me the order of impact. And there's always going to be discussion about prioritization. What I do think you can automate by now is you can inventorize all the key risks on these non-functional aspects, like security, like maintainability, like reliability, and get them automatically indexed. So backlog of technical debt, which is often made by hand in many organizations, you can automate that. Even to such a degree that if you make a commit in a software system, you immediately get an updated backlog of all your technical debt in your entire landscape. That is now possible. And you can do that over any development language that you might have in-house, especially larger organizations. They might have, I have one client that calls their landscape a technology museum. They have everything from visual languages to older languages, scripting languages to newer languages. And so we'll show you in a little bit the platform we've designed for this, that we've built for this, that allows you to give you a technologically independent view of all the technical debt that you have over all these non-functionals. Now, having said that, do you then automatically know what to solve? No. And there's still a discussion necessary. For example, let's take maintainability, and I can also show you in a little bit. Do you just solve all technical debt? No, that's too expensive. So where do you start? Well, it's probably smart to start in parts of the application, in applications that you expect to change a lot in the future. Because any investment you make there is much more likely to provide you a nice return on productivity in the future. But for that, you need a discussion. The status quo, I think, is that many organizations are talking a lot about what technical debt they have. They have to debate where it is and whether it is technical debt, so that there's not so much time to actually talk about how to prioritize and solve it. And I think you should automate the first half of the discussion, so you can spend all your time on what is the best way to actually do something about this, and also include multiple roles in that discussion.
Yeah, very interesting. And I think there's another question from the audience.
Great.
That talks a little bit about that, and it actually goes back a little bit also to that process side maybe of technical debt. And I really like that. It's like, would you also say non-conformance to the organization standard could be qualified as technical debt?
I think that's exactly right. So if you run an organization and you say, and you sometimes meet these managers, they go, we are the best in security, or we need the best resiliency, and we need the most cloud nativeness and the highest scalability. And then you show them the hypothetical bill for these things, that's unaffordable. That's just not possible. And you cannot, you need to make trade-offs there. So what level of security are you comfortable with? What degree of scalability is really required for your business? And what I see in practice is that developers are often, in hindsight, when something is wrong, then they're blamed. Hey, it's not resilient. But it was never a really clear requirement. So when is it resilient enough? What is the uptime that you need? How quickly does it need to get back up? And how much can we spend extra to have sort of all these patterns in the way that we deploy our systems in our landscape?
Yeah.
So to get back to your question, what you want is for people to really make clear decisions on this is what that means for our organization. And then you can measure compliance or non-compliance. But just saying, you know, these are a long list of violations or things that are wrong, it's not very productive. It's not really specific for an organization.
No, exactly. Thanks for that, Werner.
Let's go to the next slide, which is the last slide. When we talk about technical debt, I think we talk a lot about refactoring. which means trying to figure out what you said, where your technical debt is, and prioritizing it and finding time for it and convincing management that you actually need that time and that it has really bad ramifications if you don't, etc. But I think in the meantime, you have a lot of responsibility as a development team, as developers, as people responsible for development teams, to prevent technical debt. So I don't know I've asked around, there's not a clear English translation of the Dutch saying, dweilen met de kraan open. Some of you speak Dutch, and it means essentially that you're cleaning, you're mopping up the wet floor, but you're not closing the faucet. So this idea behind, if you prevent technical debt, you also don't have to actually solve the technical debt. Now, of course, you inherit a lot of technical debt, but it's very important that you do not make it a bigger problem as you're working. So there's actually a lot. Today, just an hour ago, I spoke with somebody from a large Dutch organization who are part of a large international organization, where it's the rule that if you make changes to a piece of code that might have existed for quite some time, large organization, older applications, you need to leave it better. This is the well-known Boy Scout rule. So in the forest, when you're going to walk or when you go diving, there might be scuba divers here. The idea is, of course, you take a little bit of trash. If everybody takes a little bit of trash, then on average, we're helping, at least as divers or as walkers in the forest, hikers, to make it slightly cleaner. And the same, of course, you can do with code. Leave it a little bit more readable, a little bit more compliant with what is maintainable, or green. And depends a little bit on what you find important as an organization. You can make agreements on this and automatically measure this. So that you can prevent introducing new technical debt. Now, I talked about these discussions about what then is clean, when is the code good. There was this question earlier that Mark said about compliance. Maybe we can share the next poll.
Yes.
The next question has to do with the type of the majority of people, the different types of roles involved in actually discussing technical debt. Because of course, technical debt sounds horrible, sounds like something that they need to deal with in the development environment and something for developers. Of course, it really isn't. The metaphor is meant to involve multiple different people who normally would not be part of this discussion. So I'm curious how this is in your organizations.
Does the poll show up?
Not on my end, but I don't think I'm the... Should it show up? Let's see.
It should be launched right now. Yes, I see also the answers coming in. So that's obviously, that's good.
Oh, I've got this. I now look at the, I was talking all the time. So one of the participants shared a quote: "An ounce of prevention is worth a pound of cure." That's a very pretty one. I really like that one.
That's really nice. Yeah, it's about, it's indeed about like closing that faucet, right?
Yeah, it is. And I think often when I talk about this topic a lot, and then developers are, oh, well, the mess that we have to work with and the limited time that we get from management and more. And that's true. But what are you doing in the meantime to not make the mess bigger? And that can be an awkward conversation. And you're very much responsible for that. We like to call it software engineering, and then be an engineer. Act like an engineer. But developers also need to be helped with this. Sometimes they don't know about it. Sometimes they really don't get the time to do this. But it's important to also take that responsibility, I think.
And I think it's interesting because it's about, especially when you say about the time. This time I can see some, I can see the answers. So I'm going to stop the poll because I think most people answered. And I am going to share the results, which I think you can see now, right?
I cannot.
Well, I really jinxed it at the start of this.
Don't say that again, Mark.
Yes, I won't. But essentially what it says, we asked, who do we collaborate with in the organization to resolve technical debt? The first answer was collaborate. No one cares about organization. Luckily, that was not chosen.
Okay.
But all of the answers went either to my team, or my team and other IT teams. And also no one said my team, other IT teams, and the business. So it seems like the business is not really involved here when it comes to collaborating to tackle technical debt. So I think when you talk about like you need to be given the time, I think there it feels like there's tension on that point. Like because a lot of times you do align those priorities with the business, right?
Yeah, but they do need to find it important, so I still see this tension of business going on. Software is where that's for the software people. On the one hand, they're saying, "Did you know we're a software company?" But they don't always want to live through the consequence of that. That means that you need to be far more involved, and it doesn't mean that you need to understand the cape complexity or write a bubble sort on the whiteboard as a financial manager. But it does mean that you need to have interest in the ramifications of decisions that are made on the development level. One of my favorite examples is open source health that we measure. That's the use of open source libraries. That's great. Use as many as you can, because it's great that somebody, the open source market is writing functionality for you that you can use. You don't have to write yourself. But it comes with all types of responsibilities, and one is that the original developers of these libraries decide on a license. So there are rules under which you can make use of the library, and these licenses can be pretty problematic for larger organizations. And so they might require that if you use this particular piece of code, you need to open source the rest of the code that you use it in. And companies don't know about this. We do a lot of work also for investment organizations, private equity. They care. If you then say, well, there's a lot of, that we see these 90 libraries that require that you open source the system, they go, solve that before we continue with any deal or any investment. And then people can be angry with development and say, how dare you? But if it's not clear that there's a degree of risk appetite, this responsibility lies with the chief legal. Well, the chief legal is not going to, look for libraries on the open source market, but it's up to development to say, hey, we have to make choices here, and it's up to you. It's your responsibility to have an opinion on that and to set a clear policy about that. And so it is definitely the business and management that needs to be pulled into this. But we still have some work to do there.
Exactly. Well, maybe on that topic, you said you wanted to share some things, right?
Yes.
So I'm going to stop sharing, and then you're going to share your screen. So that's always an exciting moment. So I'm going to give the floor to you, or the screens to you.
Let's see what happens. I should be showing a screen. This is a web browser. This is Safari, which is currently visiting Sigrid. Sigrid is our platform. So as an organization, we've built a platform that does automatic inventarization of non-functional aspects of software. That's a mouthful. It just measures quality at scale automatically. And it's not so interested in giving you long lists of things that are wrong with your system, saying violation here, violation there, because it's very easy to give 100,000 violations easy at our larger clients, no problem. It doesn't help you because you don't have time to solve 100,000 violations. What you want, which key violations do I actually need to pick up to address technical debt that matters to my organization. So this system is built up around the idea of objectives, which is that policy that we talked about earlier, also that question that Mark mentioned earlier. And so for a portfolio that you have, the portfolio that you see here has probably some recognizable systems. So MariaDB and Blender and MongoDB, of course, these are all open source systems that we can share. These are 84 systems, 84 applications. And for these applications, you can set objectives. So we don't want you to write the best possible software system, because as I said earlier, you will go bankrupt. And that's not an objective. It needs to be good enough to serve your business. And for that, you need to be very clear in setting policy. What you often see is that development teams are pretty autonomous in how they do things, sometimes so autonomous that they get to pick their own technology. And it's fine. Team autonomy is important. I think we've learned that in the past, I would say 15 years, that it's important to not tell developers, don't micromanage developers. They know what they're doing, but they need some help when it comes to company risk appetite. I think I gave some examples around security, around license use, for example, but there are many other topics. I think maintainability is a very important one. So what you do is you say, for certain systems, let's say systems that I am currently starting to build, so systems that are in the life cycle phase evolution or initial development. And these types of information you can actually integrate with your CMDB. So you might already have that information available. If not, you can set it here. And say these systems need to adhere at least to a certain level of quality. a certain level of maintainability, to be more specific. And when you don't, well, it's not, you can decide as an organization what you want. Some organizations are really strict. They say, sorry, no check-in. If you do not check in, sorry, if you don't comply, you cannot pass your build pipeline. That's a bit strict, but it might really be important for an organization, of course. But it says, for example, if your deployment type is public facing, then quality level of maintainability needs to be even higher. And you can then apply this to a subset of your systems. And so those systems, for example, that are new. Your legacy systems, you might not care that much. You might be interested to see how much work is actually being done at all on these legacy systems, because many organizations would expect no effort is being spent there. That's not always the case. Sometimes far more effort is being spent there than you would think. Of course, you could see these types of things here. But this is where you set the policy. In my experience, not many organizations have yet set these central policies. And so there might be code style guides, which is not quite the same as writing maintainable code. There often is architecture. There often is a design that might be written in either UML or in some kind of case tool, or maybe on a big piece of paper on the wall. But of course, to actually measure compliance, many organizations still have to look at do spot checks. And somebody actually, an architect actually has to visit a team and look at what they have built. You can also measure compliance with architecture. It's a bit beyond the scope of this particular webinar to really go into that, but that's a very interesting topic in itself. License use, I just talked about. So what type of licenses do you accept? So do you accept certain copyleft, as they're called, implications of your license, or don't you? And there's some degrees in there that you can actually decide on. You set that, you report on it, and you can look at your entire landscape whether you comply. Now you can use it in two ways. You can mop. That means that you log into this system and you actually look on the entire. Let's go to open source health, for example, which I just talked about. And you can look at where do I see open source licenses that I don't like and that are very problematic. But you can also use it as closing the faucet, where you're like, I don't even want to log into the system. I want my developers to develop. And the only thing that I want is for them to see in their pipeline if they actually don't comply. And so they get a remark saying, hey, this is not completely in line with what you want. By the way, all of that is online. So there's this page called docs.sigridsays.com, where you can find all of this information. So this is, for example, what the maintainability feedback looks like in the pipeline. It's very simple to actually set this up and to get this information to your developers. And so this is on the prevention side of things. There are different ways of now looking at what's being developed on. For developers, it's interesting to see also over a certain amount of time the type of changes that they did and what they did to their maintainability. And you can also zoom in to particular examples, for example, security that I talked about, security types of findings, and figure out on a source code level how to actually solve those types of findings. Any questions so far, Mark?
Not in the chat, but I do want to indeed give people now the time that if they have a question of anything that Werner just showed, or just a question that you might have in general, working with us for the past months or years, that obviously right now is your chance to ask it. But in the meantime, I would say, Werner, do go on.
Okay. There, of course, are different angles of what I could show. What I always find interesting is an important view that you can take when you want to decide what technical debt to work on, is to figure out what type. So I zoomed in on one particular application here called Elasticsearch. And there are different ways of getting to the same bits of information. I'll pick the more technical angle here. So I'll go to what we call the Code Explorer. That means that I can actually navigate the entire Elasticsearch code base, which is big. So it takes a few seconds for it to show everything on screen. There we go. And I can try to figure out, as I know, for example, XPack is an extension for Elasticsearch. That is something we really need to work on. in the coming months. And that's really a key thing that we either need to extend or that we need to work on. So I can look at, for example, let's just pick your file. This is Python script here. And I can look at particular instances of technical debt that really matter here. Let's take security, which is always very nice. There's a CVE code score here. So I can really focus on this particular one. This is a critical one. So remember the 3 bars that I showed. So it's very likely that this will not take a lot of discussion internally, that this should take priority when you pick up a technical debt finding here. Well, I find this a bit complex. Actually, I really don't understand it. So I need more explanation. I just jumped into this particular security vulnerability. Again, I still find it a little bit hard. There's an explanation here, what it really is. It seems to be an input validation problem. So it really explains what are the technical risks, give me examples here, and explains also what the business implications are when this is being abused. So what are the potential implications? And I still find it really hard. So can you please, we use also our own local LLM. This is our own. That then explains to me what does this particular code actually do. So it's more than actually explaining to me how this particular finding in theory works, this types of security finding, but also how particularly this piece of code is constructed. So I can even better understand how I could rewrite this piece of code.
So I think there's a question that came in that pertains itself to kind of the old legacy systems. And the question is about like, what can I do or what should I do for systems that are already scoring very low? Yeah. So I was like, how should I refactor my low scoring system?
Yeah.
Because essentially, and this is kind of what me filling it in, but what I've heard a lot is like, yeah, I have this system that's already scoring very low. If I make a few changes to improve it, it's kind of it's a drip, it's a drop of water in the ocean.
Yes. Yeah, so that's why so the question is, why would you want to refactor a legacy application, and what are the particular risks there? So what I while you were talking, I was clicking around. I went to this portfolio overview, and I grouped these systems. So each tile that you see here pertains to one of those, corresponds to one of those 84 systems here. I picked lifecycle phase, and this was metadata that's available about the system. And you see here, these are the systems. And of course, these are example systems because I'm quite sure TensorFlow is not yet end of life in reality. And so you can see, I want to see those particular systems and I want to look at their quality. Let's pick TensorFlow as an example. And you can't really decide now, I need to make this better. In fact, that is a problem in many organizations, that because there's no policy around refactoring or technical debt management, developers might decide, well, there's a part of TensorFlow that I dislike. And if I have a little bit of time, I'm going to make that prettier so that it's easier to develop upon. But the question is, this is now this invisible budget that you've spent on refactoring a part of this application. Was this the best bang for your buck? Maybe not. And so it's of course great that a developer takes this effort, and it's amazing that they have the mental capacity to work with a large legacy code base. That's not simple work, but what did it deliver in the end? What did it bring to the sort of the service that you have on the business end? Maybe not so much. And maybe what you need to do is decide not to spend that effort on the legacy system. This is one way of answering your question. Maybe
maybe the other way that's indeed one way to tackle it. The other way to tackle it is like, let's say you did decide together to make that improvement.
Yeah.
But the system is maybe very large.
Yeah.
In that sense. And like, how do you then still see you're navigating into the right direction?
Yeah. So one way, let's take the maintainability angle, there are many angles to talk about here, is that what we look at here, I was clicking around again, I'm still in TensorFlow. And what I did is I went to what we call delta quality. So indeed, especially legacy systems tend to be large, they're big, so the systems usually grow. There's not much deletion taking place. I don't know why, but it's typically they only grow. If you do something great in the corner of that system, then of course the total amount of technical debt is relatively unchanged. You can have an opinion, though, on the quality of the change. Remember when I talked about this Boy Scout rule, when you leave it slightly better? So what you can do is you can look at the quality of the newly written code. Then you can written at how much, what is the distribution of new code that you've added that's actually pretty good. So then, of course, you won't see it on a large scale, but you can have an opinion on the quality of the work that's being delivered by a development team or by an individual developer. It's not so interesting in this. You cannot do this in a system, point out to one person, of course, because it doesn't help. But it is interesting to know whether a team is capable of actually getting to a certain level of quality, because maybe they need more time or training or other help to actually get them to a level where you agree on together. You can look at the change code that they did. You can look at a combination of that code that they actually committed, and you can look over specific periods of time. And so often it's nice if that corresponds with a sprint. And so what is, you can use it as part of your sort of retroactive, where you look back, what have we done this sprint? And what can we do better next time? What did we learn? And specifically from my quality perspective.
I think that especially what you said in the end, it's something that when I talk to customers that are using Sigrid a lot, and they're like the best practice users, bringing these screens into already existing sort of processes, like the sprint retrospective, really helps, because indeed it allows that collaboration between people, and it allows that conversation to happen on things that are almost always otherwise considered as that black box.
Yeah, and it objectifies. Mm-hmm. So it's important that quality, of course, is a difficult word. So what is quality? And then people go, oh, they have an opinion on it, and there's some sort of subjectiveness also to it. It's important that you make that clear. And so for maintainability, and there's an ISO standard for this that really makes very clear how to look at it, and we operationalize that. So you can actually measure it, and it looks the same in Java as it does in Perl or in TIBCO or in COBOL. So you can do that, and then you can agree. So when is a unit too big? When are there too many decision points in a unit? And then we essentially can do research on how many decision points fit in a human head. Well, about 7. And after that point, it gets really hard to understand what a unit does, let alone write a unit test for it. It's very hard to write a unit test for a very complex unit. And so you can. It's important that you make it very concrete and operational, that you can agree. Okay, this is what we all think is quality, because it's already hard enough to have a discussion that you will still need to have about what to do about it, how to change it, who is involved in that, and not so much in what is good or what is bad, because that takes a lot of effort. It also takes the effort and time away from what you need to be doing, getting stuff done.
So we're slowly catching up to the hour. We still have one poll, and I still want to spend the last 2-3 minutes talking about next steps, or at least kind of what, like rounding off, and also in asking people to go into the to join the next AMA session if they want to. Mm-hmm. But I think one thing that kind of stuck with me, and it kind of, while you were talking, I was mulling it over in my head, is that point on bringing the business in. And you've been working at SRG for 12.5 years now. Congrats on that, by the way.
Thank you.
I'm still wondering, and actually there's another question coming in, so there's 2 questions. But we do a lot with ITDDs, right? So one company buying another company, and there we very much quantify in euros or dollars that technical depth.
Yes.
How do you see that resonating with the business? And is that something that we could potentially bring more into, let's say, the normal way of development? Or is that, like, how do you see that?
Yeah, so money talks, and they love it, because there's so many different ways that we've tried. I say us, I very much count myself as part of the tech nerds, the developers, the people who like graphs and formulas. There's so many ways that we've tried to convey information about software findings, about IT problems. A list of things, traffic lights, thumbs up, thumbs down. In the end, if you can quantify and say we have a security vulnerability and it will take 3 person months, which comes down to so many dollars, they understand that. That's finally somebody who just makes a translation to something. What is the impact? Also, because you can huge security finding, 2 person days. that can be the case with a security finding, right? It's actually not so hard to solve, but so it's important to actually make that translation. It's always sometimes it's also the other way around, of course. So it's the short answer to your question is, if you can try to make it into dollars or euros, that is always the best way, and it's possible much more often than you would guess.
Yeah, and actually, I think this is a question that we got from someone in the audience, and that is very much a rounding up of what you've talked about in the last 55 minutes. Is would you be able to help listing the benefits of solving technical debt for debt? Sorry, I keep using the B in there, and it's not.
Yeah, we're Dutch. As Dutch people, it's hard.
Exactly.
Yeah.
I just want to like pronounce all the letters.
Yeah.
That's why I was horrible at French in high school. But
is there? Yeah. So French
different story.
Yeah.
Different story. But would you be able to help listing the benefits of solving technical debt for different types of stakeholders?
That's a big question in that it's different stakeholders, different debts. So you get a Cartesian product. It's a big table, right? So it's for different. It is important to think about what type of stakeholder do we have to talk to and what are the implications for them, and only talk through the lens of what the application is for them.
So would you say like business try to link it to potential like money? Would that then be, and maybe architects?
Well, for PE, for private equity, it's money, because you're talking a deal, you're talking they want to invest X and they have assumption Y, and then you can say, well, that's okay, your business case can be made, but this is what you still extra need to invest. And for them, that immediately fits into, okay, these are the implications. For business in general, that's harder to say, because it might be money, it might be time to market. It really depends on the domain. It might be very important to have impeccable service for your reputation, right, in certain domains. So you need to make a translation to something that really matters to that particular organization. So that's a key question. And are they going to sell more beer because of this? Are they going to sell less beer for this? Whatever, to make it really, really concrete and tangible for that particular organization.
And maybe for things like for stakeholders like architects.
Yeah.
Right. Like what because those also run around in the business.
Yeah.
Like how do we make this important, and how do we tie this to something that they care about?
Yeah, and for them it's extra important because they essentially only tell you no, right? So they have some clear rules that component A shall never talk to component B, and then everybody goes, yeah, but that's much faster. And they go, oh, we thought about this architecture, and then they need to and they're found to be inhibitors and slowers down, and they are in a way because they come up with policy and rules, and they need to check, and they continuously need to talk to yes, but the implications are these. And I think that's not always easy for them. The hard thing for architects, of course, is that they don't scale. So they have to talk. They go to different groups and sections, and they continuously have to do sort of spot checks and talk and convince and talk. And so it's important that everybody talks in that same way, and that you automate certain parts of that work.
Nice. Thank you, Werner. I think that is a very nice question to end this with. I want to thank you for your time today during the session. Do not forget, if you're interested in the next session, to sign up for the next session on architecture in specific. I think there's a lot to uncover there. I think, Werner, you already mentioned it a few times, kind of the value that architecture can have, and then also kind of what we as SIG kind of do in that realm and space, and how we can help you with that. So I am going to see if I can find I can end the poll. Thank you for all the feedback, and I want to say have a great Easter.